Hello everyone, welcome to our channel. Let's learn together. So in this video I'll be starting with the remaining standard forms of Laplace transform. In my previous videos I've made a few Laplace standard forms of Laplace transforms. Please do check them also. Now let's start with this fourth standard Laplace transform. Okay. First, before deriving anything, the standard form of Laplace transform, just remember this formula always. Okay. Now what we have to do, we have to find the Laplace transform of e power at. So now substitute in this formula, Laplace transform of e power at is equals to integral 0 to infinity e power minus st f of t. F of t is nothing but e power at dt. So now we know that a power m into a power n is a power m plus n. Similarly, this is in the same form, right? Integral 0 to infinity, we can write this as e power minus of s minus a into t dt, right? That is whatever you can also write in the form of e power a minus s into 2, whatever, it is fine. Now integral e power at is e power at by a. Similarly, here you can write this as e power minus of s minus a into t by s minus a. Sorry, minus also, right? And apply the limits, that is 0 to infinity, which is equals to, now we have to apply the limits, right? E power minus upper limit minus lower limit. Upper limit is e power, in the place of t you have to substitute the limits. E power minus of s minus a into infinity. So e power minus infinity is 0 and e power infinity is infinity, right? So this whole thing will become 0 minus lower limit. So lower limit will be e power minus of s minus a into 0. E power 0 is 1, right? So 1 by minus of s minus a. So you can write this as 1 by s minus a. Okay. Therefore, the Laplace transform of e power 8 is 1 by s minus a, where s is not equal to a. Now similarly, I think we can also write the Laplace transform of, the fifth Laplace transform, if it is, if f of t is e power minus at, then what is the Laplace transform of f of t? That is Laplace transform of e power minus at. Without deriving itself we can write, right? If Laplace transform of e power at is 1 by s minus a, then what will be the Laplace transform of e power minus? Without derive, if you want you can derive, but I am writing it directly because same step, right? Just the change of signs will be there, which is 0 to infinity e power minus st into e power minus at dt. So which will be equal to Laplace transform of e power minus at will be positive sign, that is 1 by s plus a, right? So this is the Laplace transform of e power minus at such that s is not equal to minus a here. Okay. Now we'll start with the next Laplace transform, that is if f of t is sine at, what is Laplace transform of sine at? Okay. So now Laplace transform of sine at will be, so integral 0 to infinity e power minus st into f of t is sine at dt, right? If you want, you can do the integral uv or the method which I have told in the previous videos, right? So that you can follow, or we have a direct formula for e power ax sine ax, or e power minus st sine at. We have the direct formula, you can simply do that. Okay. So without extending this, without making this more complex, I'm just telling you the direct formula. So the formula for this will be e power minus st by a square plus s square. S here is minus s, right? minus s whole square into minus s sine 80 minus a cos 80, and apply the limits for this whole thing. Or simply, if you want the direct formula, I'll just tell you what is the direct formula. Okay, so the direct, or I think you can just do the integral u, right? I have explained in the previous video. Please do check that how we can do integral u. Now let's apply the limits. Okay, however, just write more, expand this so that you'll not have more confusion. A square plus s square, right, into minus, I'm writing it here, into s sine 80 again minus a cos 80 into e power minus st by a square plus s square. Now apply the limits. Okay, upper limit minus lower limit. So upper limit is infinity, so e power minus s into infinity, which is nothing but it will become 0 only, right? Again 0 minus, and here also you have to apply the upper limit, right? Here also e power minus st, which means e power minus infinity, this will also become 0 minus lower limit, right? For lower limit you have to apply for this also. Lower limit, that is e power 0. E power 0 is 1, right? Into s into sine a into 0 by a square plus s square minus this minus a into cos a into infinity and e power you have to apply a lower limit, right? A into cos 0 into e power 0 is 1 by a square plus s square. So this will become 0 minus sine 0 is 0, this whole thing will become 0 minus a into cos 0 is 1 by a square plus s square, which is minus of minus will become plus, a by a square plus s square. Therefore Laplace transform of sine 80 will be a by s square plus a square. Okay, now we'll find the Laplace transform for cos 80. Similarly, just as sine 80, Laplace transform of cos 80, which is integral 0 to infinity e power minus st, f of t is cos 80. And as we have the formula for sine 80, we have also the formula for integral e power minus st cos 80. Or you can apply integral uv, that's your choice. Now I'm simply writing the direct formula for integral e power minus st cos 80. Okay, so the formula is e power minus st by a square plus s square into minus s cos 80 plus a sine 80. That is the formula, and the remaining limits you have to apply 0 to infinity. Same as sine 80, just multiply with this e minus s into e power minus st by a square plus s square. I'm so sorry, minus I'm writing here, and s cos 80. Okay, now plus a sine 80 by a square plus s square into e power minus st, and limits are 0 to infinity. Now apply the upper limit and lower limit for both these things. First apply the upper limit. E power minus infinity is 0, so this whole thing will become 0 plus here also e power minus infinity, so this will also become 0. We have applied the upper limit. Now we have to minus lower limit, right? So apply lower limit for this. E power 0. E power 0 is 1. So e power 0 is we have to apply lower limit for this, right? E power 0 is 1. So minus s cos a into 0 by a square plus s square plus apply lower limit for this. A sine a into 0 into e power 0 is again 1 by a square plus s square. This became 0 minus of what is cos 0? Cos 0 is 1, right? Minus s by a square plus s square. Sine 0 is 0. So you will get it as s by a square plus s square. Therefore, Laplace transform of cos at will be s by a square plus s square. Okay. We'll learn more standard forms in upcoming videos. So please do check all the previous videos of standard forms of Laplace transform also. Thank you. Thanks for watching. Do like, share and subscribe for more videos.